Hi everyone, this video is for section 9.1 where we will be looking at hypothesis tests for two population proportions. The question that we'll be looking at reads, many high school students take the AP tests in different subject areas. In 2007, of the 144,796 students who took the biology exam, 84,199 of them were female. In that same year, of the 211,693 students who took the Calculus AB exam, 102,598 of them were female. Is there enough evidence to show that the proportion of AP biology exam takers who are female is higher than the proportion of AP calculus exam takers who are female? Test at the 5% significance level. Our first step is to state the random variables and the parameters in words. In this situation, we are going to have two random variables, one representing the group of females taking the AP biology exam and the other group representing the females taking the AP calculus exam. So the good news is once you begin to define one of them, you can use that first one as a template to define the other random variable, and you can also carry this over into defining your parameters. So for example, let's go ahead and start by working with P1 hat. And I'm going to define P1 hat as the proportion of the 144,796 high school students who took the biology exam that were female. So what I want to call out here is, again, P1 hat, our random variable, is talking about our sample. So this is why I included our sample size. Also notice that I did include details such as that these were high school students that we were looking at, as well as the specific exam that they were taking. So what I would like you to do now is go ahead and pause the video, take some time to define the other random variable and the two parameters before we progress forward. Once you're ready, press play and we will review these solutions. Okay, so before we move to the next step, please take some time to review what you had written for your random variables and your parameters. Make the appropriate adjustments if you need to. For our next step, we want to state the null and alternative hypotheses and the level of significance. So straight away, I'm going to call out that our level of significance, or alpha, is going to be equal to 5%. This came directly from the narrative that we had just read through. With regards to the null hypothesis, which we indicate with h sub 0, we are assuming that the proportions between the two different groups are equal. So we are going to say P1 is equal to P2. Please notice that I did not use P1 hat and P2 hat. Your hypotheses are always going to refer to your population. So this is why I use P1 and P2. So again, these are referencing our population proportions for the proportion of students taking the biology exam who are female and the proportion of students who are taking the calculus exam who are female. For our alternative, h sub a, we are again going to use P1 and P2. We just need to know the direction or which inequality we should be using, less than, greater than, or not equal to. And in order to determine that, we want to go through and read through that last question in the narrative. Is there enough evidence to show that the proportion of AP biology exam takers who are female is higher than the proportion of AP calculus exam takers who are female? So because I am seeing the word higher, I'm getting a very specific direction to move in. So higher makes me think greater than, so I am doing a right tail test. Next, we're going to state and check the assumptions for a hypothesis test. First are both simple random samples. The narrative doesn't explicitly state this, so we are going to assume that this is true. We're going to assume that the researchers went ahead and randomly sampled both the biology test takers and the calculus test takers in order to compile both of those samples. So we're going to give this a check mark, assuming that it's true. Next, are the samples independent from each other? I think we can make the argument that they are. So someone taking a AP biology exam is not necessarily going to impact someone who is taking a calculus AP exam. If we are also working underneath that original assumption of these samples being randomly sampled, and also the fact that we're probably randomly sampling students from across the nation, we again are kind of justifying that further, that this is probably that these samples are independent of one another. If we are working with nationwide data, then that hopefully means that we are less likely to have the same student appear in both of those samples. Moving on, do both use the same two categories? Yes. Two categories that we're working with here are male and female. Now we want to note if each sample has 10 or more successes and if each sample has 10 or more failures. Depending on the textbook that you're working with, they may use 5 instead. I'm going to go ahead and work with 10. I don't have to worry about the formulas that I have laid out here. I actually already know the number of successes, in other words, the number of females who are taking the biology exam and the number of females who are taking the calculus exam. If we return to the narrative, we note that there were 84,199 students who were female that were taking the biology exam. And we also note that there were 102,598 students who were taking the calculus exam that were female. So clearly both of these numbers are bigger than 10. So then we can go ahead and move down to count how many failures we had. In other words, how many of these students taking each of those exams were male. So again, going back to the narrative, we know that there were 144,796 students, and we're going to remove the 84,199 female students to reveal that 60,597 of those students were male. And then for the calculus group, out of the 211,693 students, if we remove the 102,598 female students, we see that there were 109,095 male students. So again, these numbers are both well above 5 or 10. The last bullet point is just asking us, do we know if the population size is greater than or equal to 20 times the sample size used for each group? And really, I would say we don't really need to worry about this. We are good to go ahead and move forward. And I really should update that last bullet point. So really, I should be talking about the entire population of students that are taking the AP biology exam. Is that greater than or equal to 20 times the sample size of that group that I worked with? And is the population size of students who are taking the AP calculus exam greater than or equal to 20 times n sub 2? Again, we really don't need to worry about this bullet point. Really focus on the number of successes and failures being greater than or equal to 10. Next, we want to go ahead and name the test that we're going to use. And since we are dealing with two proportions, we are going to go ahead and work with a 2 proportion z-test. To find the sample statistics and the test statistic, we're going to use our TI-84 calculator. Hopefully you've read through your textbook on how to do this process. What I would encourage you to do now is to take the time to practice that, pause the video, go ahead and work out your solutions, have them written down. When you're ready, press play and we will review that process. Okay, going through the calculator steps, you would first press Stat and arrow over to Tests, which is going to be in the header on your screen From there, your screen will change and you will get a new list of options where you will select option 6 to Prop Z test. Press enter and that will take you to a new window. From here, you're going to want to enter in the following information. So x1 is referring to the number of successes, in other words, the number of females in our first group, those taking the biology exam. So 84,199. N1 is our sample size of 144,796. And likewise, we repeat that for our calculus group. 102,598 were female out of the 211,693. Lastly, we are going to indicate which tail test we are working with. We said our alternative was using the greater than symbol, so we are going to use greater than P2 here. The items that you see in purple are the output that you get once you calculate. So as you can see, we get our z-score, or our test statistic, and then our sample statistics appear as P1 hat and P2 hat. The P hat that you see below is if we pooled everything together. We don't really need to worry about this number. And you can see that N1 and N2, those are just your sample sizes repeated again on the screen. The P that you see, I'm going to call this one out in a different color. This is your P value, so that answers our next question below. So what I want you to note here is that your calculator is going to have a part of the number be e raised to the negative 88. So to be clear, this is the calculator's way of doing scientific notation. So this is actually saying 1.087954 times 10 to the negative 88. So really what we would want to do is locate that decimal point and start moving it to the left 88 times. So even if we were rounding to like the second, third, fifth decimal, this is effectively saying we're getting a p-value equal to 0. There's something wrong with that. I'm just telling you that if you were to try to convert this number in scientific notation to standard form, it's essentially just going to be 0 no matter how you round it. So now we can make a decision about our null hypothesis. So remember, in order to do that, we need our p-value and we need our level of significance. I had mentioned that our p-value was effectively 0. Our level of significance was 5%. Well, 0 is definitely less than 5%. And remember, when your p-value is less than your significance value, this tells you to reject the null. Basically, we're saying that the results that we got from our sample are so extreme if we are working under the assumption that our null is true. So we don't really expect to have something rock our world that much. So that kind of tells us that maybe something has changed since the last time we had looked at it, or maybe our assumption is incorrect. So we're going to move back to kind of like more stable ground in a way. This is where we are rejecting the null and we are beginning to support the alternative hypothesis. So next I want you to take some time to state the conclusion in the context of the problem. So what I would like you to do is press pause and work on this. The main thing that I want you to remember, include the following 3 things. State the level of significance that you're working with. State just in general, are you rejecting the null hypothesis or are you failing to reject the null hypothesis? And lastly, include context in your final solution. Okay, go ahead and press pause, work on it, and then when you're ready, press play and we will review. Okay, so we should have something along the lines of at the 5% significance level, we reject the null hypothesis. So again, calling out that significance level and just our general conclusion. And then finishing that by maybe referencing your definition for your parameters or going all the way back into the narrative and referencing that final question that was posed to us in order to begin work on the hypothesis test. We have sufficient evidence to support the claim that the proportion of AP biology exam takers who are female is higher than the proportion of AP Calculus AB exam takers who are female. I hope this was helpful.